Okay, baseball fans, I hope that you have already watched the vertical asymptote video because the domain of rational function is basically going to be those answers, but kind of the opposite. So that was a little bit confusing. What does that mean? Let's start off with our basic parent function for rational functions. And you guys, again, this is rational functions we're talking about. So keep that in mind. And it works for other functions, but it may just show up a little bit differently, right? 1 over x, my vertical asymptote here, you just watched this video, it's x equals 0 because that's where it does not exist. So the domain of the function is where it does exist on the x, right? The domain, and we've talked about this before, is where the function does exist on for the x values. Okay, so how do I write this? If x equals 0 is where it doesn't exist, okay, then where it does exist is from negative infinity to 0, but not including. That's what and I know we've talked about this, not including, that's why these are curved. If it was including, it would be square brackets. And then, and this is why we have to have 2 because it doesn't include 0. And then 0 to positive infinity. Positive infinity. And this is called interval notation. Okay. How else can we write it? We can say where x is greater than 0 and where x is, I kind of wrote this backwards. I mean, technically it's okay to write it that way, but I don't like it. Let's see. Where x is less than, nope, you guys, I liked it the other way. Where x is all the numbers greater than 0 and where x is all the numbers less than 0. Okay, so here x is greater than 0, here x is less than 0. If it had been in between, it would have been a little bit easier to write that way, but as an inequality, this is what it looks like. Interval notation, this is what it looks like. If it's just one value where it doesn't exist on the domain there, you can also say the domain of x just does not, the domain is all reals, but does not equal or accept, okay, or accept 0. You can also write it like that. That's acceptable. I think we're going to really need to start getting into remembering how to write it as interval notation. That's definitely the least confusing, maybe the most work to remember how to do it, but definitely looking at everything I just wrote, also the least confusing about where the actual function exists, right? So let's do another one here. Let's do another practice problem. How about x squared minus 16 over x squared plus 6x plus 8? Let's go ahead and factor this. So if I factor the numerator, sorry guys, that went a little bit wonky, didn't it? If I factor the numerator, we're going to have x minus 4 times x plus 4. Okay. And you can check that if you want by multiplying them together using our area method or the squares. It kind of looked like lattice. In our denominator, two numbers that add up to be 6 and multiply together to be 8 should be x plus 4 times x plus 2, right? So we know we're going to have a hole here. There's going to be an extraneous solution. There's going to be a hole at -4, extraneous solution And that's because these cancel out, so it's not, my domain's not going to exist there, right? And the other one is x plus 2, so that one's going to be -2 would make it 0, so also at -2. This is going to be a whole vertical asymptote, though, and this is going to be an extraneous solution, right? So let's write that in interval notation. So it exists from -∞ all the way to what's our smallest number, -4, but not including 4, all right? Because it doesn't include 4 because that's where it doesn't exist. Then from -4 up to -2. Doesn't exist at -2, so then we go -2 to positive infinity, okay? And that's how we write the domain of that function in interval notation. We're writing where it does exist. So the asymptote is where it doesn't exist, but it gets super close to it. And the domain is where it does exist on the x, right? So the vertical asymptote does not exist, okay? But the domain, and we're only talking about for the x values, right? The domain is where it does exist, okay? So that's the two different, they kind of complement each other. They're opposites of each other. You have to find one to get the other. But I know it can be confusing, so I'm going to add maybe some more practice problems to that. You should already have them on your paper. And please call me over if you need any help for that.